Sections 8.3 and 8.4 look at determinants and your multiplicative inverses of matrices. And then tomorrow we'll actually look at how to solve systems of equations using these matrices. It's way shorter, especially with doing 3 variables or 4 variables or anything like that, more than just an x and a y. But we have to learn how to do a few things before we can do that. So first off is our determinant. Every square matrix has a determinant. Note where it says square. The symbol for the determinant is just DET, or lines, almost like absolute value lines around the matrix, instead of doing some brackets like normal. To find your determinant, you do AD minus BC. So you multiply those two numbers, multiply those two numbers, and subtract. So let's actually do that. So here on number 1, I'm going to do 5 times negative 2. Then I'll do negative 4 times 3. And I'm subtracting those two answers. So I get negative 10 minus a negative 12, which would just be positive 2. My determinant is 2. Your determinant should be a number. Go ahead and pause, and following that same process, I want you to find the determinant for numbers 2 and 3. On number 2, you should have gotten 3 minus a negative 14, or plus 14, which is 17. And on number 3, you should have gotten 20 minus 20, which is 0. So those are my determinants. We use the determinant to tell us if we can find a multiplicative inverse. And so when you're thinking about your multiplicative inverse, just normal, if I have like 4x and I want to get rid of the 4, you could divide by 4, or really that's like multiplying by 1/4. So 1/4 and 4 are inverses, because 1/4 times 4 would just leave me with 1. Your matrices also have inverses, and they leave you with your identity matrix, which is just 1, 0, 0, 1. If this was a 3 by 3 matrix, it'd be 1, 0, 0, 0, 1, 0, 0, 0, 1. So this whole diagonal from top left to bottom right is 1s, and every other number is 0. Because if I multiplied anything by this, it wouldn't change what I multiplied it. Just like multiplying 1 times something doesn't change it. This is what that is for. This is your basically identity for your matrices. So how do we find the inverse? First, you find the determinant, and you do 1 over that value times, and then you take your matrix, you switch those two elements, and you make those two negative. So looking back at the 3 we just did, we already found the determinant. So for this first one, we already found the determinant was 1/2. So to find my inverse, I know it's going to be 1/2 times, and then I'm going to switch those two. So my first one becomes negative 2, the last one is now 5. And then my other two elements, I change their sign. So this becomes negative 3 and positive 4. When I multiply 1/2 by that, 1/2 times a negative 2 is a negative 1. 4 times 1/2 is 2. Negative 3 times 1/2 is negative 3/2, or negative 1.5. And then 5 times 1/2 is 5/2, or 2.5. I personally would recommend using fractions, because as we start to get into other ones, like the second one where you're going to be doing 1 over 17, those are going to be awful decimals. Go ahead and find your inverse of this second matrix. Should have switched these two elements, made the other two negative what they were to change the sign. Your inverse matrix should be negative 1 over 17, negative 7 over 17, 2 over 17, and negative 3 over 17. On the third one, when I go to find my inverse of this matrix, I'm going to do 1 over 0, times -5, -10, -2, -4, but you can't have 1 over 0. So when your determinant is 0, there is no inverse. So what if the determinant of the matrix is 0? Matrices with the determinant of 0 do not have an inverse because we cannot divide by 0. So the determinant tells us if the matrix has an inverse. So if you get any number besides 0, then you get an inverse. And then I'll show you what you can do with that. If a matrix is rectangular or bigger than 2 by 2, so rectangular matrices don't have determinants or inverses, only square ones do. So if I ask you to find the inverse of a 2 by 3 matrix or the determinant, it's not possible. You will be asked to find the determinant for 3 by 3 matrices, which there is a formula in your book on page 595. However, there is an option to do that in your calculator. Only if you are doing 3 by 3 matrices should you be using your calculator, which means that for anything else, like your 2 by 2 matrices, if I ask for the determinant or the inverse, I expect to see work for them, just like we did here.